Okay, so now I wanted to just run through the theory behind the bleach titration. Now, with the bleach, you see, you're substituting the KMNO4. Now, can I just actually, before I do any more, the previous titration, you used KMNO4 that you knew the concentration of to produce iodine in a conical flask. Then you titrated that iodine with sodium thiosulfate that was in the burette, and you were able to standardize or to work out the concentration of the sodium thiosulfate. So now, going forward into the bleach titration, you know the concentration of the sodium thiosulfate that you're putting into the burette. So you're going to be putting in Na2S2O3, sodium thiosulfate. You know the concentration of that, and you're going to have iodine made here now in the conical flask. Is that okay? Now, how are you making the iodine in the conical flask this time? That's what's a little bit different. We're not using the KMNO4 as the oxidizing agent. We're using diluted bleach. So sodium hypochlorite. Now, don't mix up sodium thiosulfate, Na2S2O3, with sodium hypochlorite. Sodium hypochlorite is the oxidizing agent that's in bleach, so it's going to be reduced itself, and it's going to be responsible now for making iodine here in the conical flask, okay? So you've diluted bleach, Ki goes in again to supply the I- ions, and the H2SO4 goes in to supply the H+ ions. So this reaction up here, reaction 1 if you like, that's what's happening in the conical flask. The hypochlorite is coming from the bleach, the I- is coming from the Ki, and the H+ is coming from the sulfuric acid, and you are making a certain amount of iodine in your conical flask. Now, what's responsible for the concentration of iodine that's made in the flask? The concentration of the hypochlorite. And that's why we have to dilute the bleach. If you poured bleach straight from the Parazone bottle into the flask, or measured out 25 cubic centimetres of undiluted bleach straight from the bottle, then you would make way too much iodine because the bleach is too concentrated. So if you're asked why dilute the bleach, you're going to say, because the bleach is too concentrated, you would make too much iodine, and then the word is excessive. Excessive amounts of the other reagents would be required. Excessive amounts of Ki, excessive amounts of sulfuric acid, excessive amounts of sodium thiosulfate would be required to react with all of the iodine that you'd made. So by you diluting the bleach, it means that you don't make as much iodine, and you do not then require such an amount of the other reagents to react with all of that iodine. Now, the dilution procedure, 4 steps, okay? So you're going to say, using a pipette and a pipette filler, you would measure 25 cubic centimetres of your bleach straight into the flask. Don't be talking about stirring to dissolve. This is a liquid. So it's like the vinegar dilution procedure. Straight into the volumetric flask. Then you're going to add deionized water until the bottom of the meniscus of the solution is 1 centimetre from the graduation mark. So add the water. And then finally, using a dropper, you add deionized water drop by drop until the bottom of the meniscus of the solution is at the graduation mark. Stopper and invert 20 times. That's your dilution procedure. So make sure you know that. Now, the other thing here with the bleach is, so the last point now is the sodium hypochlorite is the limiting reagent. So what does that mean again, that it's the limiting reagent? So this is the limiting reagent. So all of this reacts, all of the sodium hypochlorite reacts, and the maximum amount of iodine is going to be made. Is that okay? Then this iodine, this is your reaction 2 here now. This iodine then that's made in the flask reacts with sodium thiosulfate from the burette, okay? And that we're going to have to try to determine the endpoint of that titration so that we can calculate the concentration of the iodine first, and then back to calculate the concentration of the thiosulfate. We know the concentration of the thiosulfate, We know the concentration of the thiosulfate. We will use that to work out the concentration of the iodine, and then back to work out the concentration of the hypochlorite. Now, for the purpose of that, of the calculation, I'm going to use the results and stuff that they had in 2011 question 1. So if you could open up 2011 question 1, I am going to go straight down to the calculation now for a second, which is part E, okay? And it asks you there to calculate the concentration of sodium hypochlorite in moles per litre. Now, lads, remember your steps. You go into an exam, you get a little bit bogged down, but what do I do first? You're firstly going to find same steps for all of these titration calculations. You're going to find the number of moles of the liquid or solution that you know the concentration of. You know the concentration of the sodium thiosulfate. So that's your starting point. So number of moles of sodium thiosulfate, okay? 16.1 times 0.1 all over 1,000, that's a 6. So how many moles of sodium thiosulfate are you starting off with? Sorry now, I have it done out here. you are starting off with 1.61 by 10 to the minus 3 moles of sodium thiosulfate, okay? So that's our moles of sodium thiosulfate. Now, this is where the ratios are a little bit more complicated. So remember, your ratio is your step 2. Now, you know how much sodium thiosulfate, but look at this now again for a second. So I know the number of moles of sodium thiosulfate. So my first ratio is thiosulfate to iodine, okay? 2:1. So thiosulfate to iodine, 2:1. That's my first ratio, okay? So I know that I have 1.61 by 10 to the minus 3 moles of thiosulfate. So half of that to get the moles of iodine. So when you do that, then you get 8.05 by 10 to the minus 4 moles of iodine. And please, will you write down what the substance is, what the solution is? That's moles of sodium thiosulfate. So if I half that, I'm going to see how many moles of iodine. So look, I now know how many moles of iodine I made in the conical flask. Now what do? This is the moles of iodine that are made in the conical flask. My second ratio now is iodine to hypochlorite, okay? So my second ratio, so ratio number 2, iodine to hypochlorite is 1:1 from my first equation here, what's happening in the flask. I know that I have 8.5 by 10 to the minus 4 moles of iodine. So I am going to make 8.5 by 10 to the minus 4 moles of the hypochlorite, or I'm going to need, I suppose, moles of the hypochlorite, okay? Now, if I just go to this part of the board there now for 1 second. You now know, okay, that you need 8.05 by 10 to the minus 4 moles of sodium hypochlorite. But what volume? Remember, your third step is you're equating moles to volume. Now, the hypochlorite is in the bleach, okay? And you pipetted in 25 cubic centimetres of that diluted bleach into the conical flask when you were preparing the iodine in the first place. So what would you have moles per litre? That's moles in 25 cubic centimetres. So you multiply by 40, or else divide by 25, multiply by 1,000, and you get the molarity of the diluted bleach now, lads. That's diluted bleach in moles per litre. So that was the first thing they asked you for. Then they asked you for the concentration of the original bleach. Now, it was diluted, look. 25 was originally diluted to 500. So that's a dilution factor of 20, okay? So you need to multiply this by 20, and then you'll get 0.644 grams per, sorry, no, we're still in moles. Moles per litre, but that's the original bleach, okay? The bleach that was undiluted, if you like, okay? Now, the next thing they ask you for then is similar to your vinegar calculation. They ask you for grams per litre and percent weight per volume. Now, it's sodium hypochlorite. So 74.5 grams is the MR, or the molecular mass of sodium hypochlorite. So multiply by 74.5, you're 0.644, and you're getting 47.98 grams per litre. I rounded it off there, okay? And then how do I change that to percent weight per volume? Divide by 10, so getting percent weight per volume, 4.79% weight per volume, okay? So that is definitely a more difficult calculation, but you must watch the ratio. So same as before, number of moles of the solution you know the concentration of. My first ratio, okay, is thiosulfate, because that's what I know, to iodine. Now I know how many moles of iodine I've made in the flask. I can use my second ratio of hypochlorite to iodine to figure out how much hypochlorite I need. And then you have that, and you pipetted in 25 cubic centimetres of that into the conical flask day 1. Okay, thank you.